Hello everyone, welcome back to Microbiome Solutions. Today we will be discussing about a dark ground microscope. So in this type of microscope or in this type of microscopy, they describe both light as well as electron microscopy. So dark field microscopy can be employed in both light microscopic techniques and also in electron microscopic techniques, which exclude the unscattered beam from the image. So a dark ground microscope will exclude the unscattered beam from the image. So as a result, the field around the specimen, that where you have kept your specimen to scatter the beam, is generally dark. As a result, the field around the specimen, that is where there is no specimen to scatter the beam, is generally dark. When you see through your objective, the field around the specimen will be dark in a dark ground microscopy. And in optical microscope, a dark field condenser lens must be used, which directs a cone of light away from the objective lens. So it will focus only a cone of light towards the specimen and the background will look dark. So this is the picture or diagram represents the dark ground microscopy. In the left hand side you can see your light source, and this is the pathway. This triangle is showing the pathway of your light, and here you have your specimen. Okay, here you are having your specimen, and in the middle of the slide there is specimen, and stopping the condenser there is a dark ground stop. If you see here, you can see an aperture stop here. So this stop will focus the light, or which will restrict the light passing through the condenser towards the sample. So since there is a stop here, aperture stop, since there is an aperture stop here, this will focus the beam of light that is falling onto the specimen, and the scattering of the image will be limited, and the scattered light will be seen through the objective lens. Since the unscattered lights are not detected, the background will be dark in color. The unscattered lights are not detected because there is an aperture stop kept for the condenser lens. So in the right hand side, this is the same picture, represents the light pathway of dark ground microscopy. Here you can see this is the stop that is used to keep below the condenser, and here is the light source, and from the light source, light will fall onto the dark field stop, and it will focus the light. Only the scattered light it will focus onto the specimen, and which you can see directly through the eyepiece. And this is the picture of a dark field stop that you keep below the condenser to focus the light. Here you can see some holes in this. The light will be scattered, and which will come through these holes and to enter the specimen that you have kept on your slide. So the uses of dark ground microscopy, this techniques is not merely used in all the laboratories. It is particularly for the demonstration of very thin bacteria, so that thin bacteria will be able to appreciate clearly if we provide a dark background. So for the thin bacterium such as spirochetes, especially for Treponema pallidum and Leptospira, which is not visible under ordinary illumination, since the reflection of the light makes them larger. Also for the demonstration of motility of flagellated bacteria and protozoa. And the disadvantages of this microscope techniques is these images are prone to degradation, distortion and inaccuracies. You need to be very thorough in reporting using a dark ground microscopy. and the preparation and quality of slides can grossly affect the contrast and accuracy of a dark field. And it needs an intense amount of light of work since it relies exclusively on scattered light. So intense amount of light is required as it is relying on the scattered light, not on the unscattered light. That's it about a dark ground microscope or dark ground microscopy. If you have any doubts, you can post it in the comment section. And please do like, share and subscribe to my channel. Thank you.